Let's talk about computers. What's that? It's an elementary thing to know what a computer is, and as a designer especially, you have to be equipped with the basic knowledge of the computer. So yeah, let's dive deeper into this and let's see what's a computer. So chapter 1 is computers are everywhere, and if you actually turn around and see the cash machine in your supermarket, the watch you have if it's a smartwatch, the computer typing your email on your iPhone, your Android, everywhere you look, there's computers. And we use them every day, all day, whether we'd like to or not, but it's true. Computers actually had a humble beginnings, right? So, they started out as professional machines, and yeah, by the way, there's no Easter eggs on the table, so don't even look. And they started as a business machines, and actually evolved to be in every part of our lives now. So literally everywhere, computers are everywhere you touch and tap and look at, it's computers. And at least let's know what they are. So obviously we all speak a certain language, right? So I speak English and Serbian, you maybe speak English and Spanish or English and German. And computers also have their own language, and it's actually based on the binary system. So let's explore what the binary system is. So the binary system is a simple language of switch and has two states. It's a 0 and 1. It's off and on. And just imagine a simple light switch in your home where you can, turn the light off or turn the light on, right? And now you ask me, well, how the heck is that used to communicate? Well, it is used to communicate because there's a certain dictionary, like we have a dictionary of English, for example, right? Where you have specifics of what every word means. There's something very similar for binary. So this is the binary dictionary where every set of every letter is actually represented by 8 switches being turned or on or off at a specific sequence. So look at this. So you have bits. So bits are this one light bulb. It's called a bit, right? And all 8 of them are actually called a byte. And the byte is a primary and elementary unit of information with which you can communicate. But the thing is, the computer, whenever you move the mouse, whenever you type the keyboard, whenever you interact with anything at all on computer, it converts it first to ones and zeros and then executes on it. So the most primal level for computer is the binary code, and binary language is the language of computers, and it works the same as our language, right? There's dictionary. The computer knows, reads the dictionary. When you give it input, there's a layer that converts it to the language that computer understands, and then that's it. So basically, on your CPU are just transistors, and transistors are basically tiny switches, like a light switch, right? And they just turn on, turn off, turn on, as more those light switches you have, the more powerful the computer is. So that's it, nothing else. So that's when it comes to the binary. Let's now talk about computer components, because they're very important. And when we talk about the computer components, everyone instantly thinks about this guy. So this is the CPU, or as some like to call it, central processing unit. And people think, oh yeah, I need a great CPU. Give me the great CPU. I want the fastest one. The thing is, there's no component in computer that's more important than another one, because with a great CPU, you can do nothing if you don't have other components as well. And it's this magnificent interplay on the motherboard itself. So there's place for CPU, there's place for RAM, there's input I/O here, so you can connect your peripherals. So everything you do on computer is a magnificent interplay of different components working together to deliver the great experience and to allow you to do amazing things, right? So the motherboard is actually like a tiny city where, you know, all these information is driving through the highway and communicating from CPU to RAM to HDD to, you know, so it's actually, there's multiple important components. It's not just about the CPU, but of course CPU is an important part. So the second component that we're going to talk about is the RAM, or random access memory, which is a very important part of computer. So this is hard drive. Of course, you know what the hard drive is, right? And actually everything from your computer is on hard drive. And when computer actually wants to take a closer look at it and wants to analyze it and wants to tackle it, so when you, for example, open your Word document or open, you know, anything at all, it actually takes it from the hard drive and puts it in the RAM so that it can work with it, because RAM is quite a few times faster in terms of memory bandwidth, right? It's quite a few times faster than the hard drive, and because it's too expensive to create, you know, crazy fast long-term memory, they created a very slower hard drive so that you can save more, so that you have more space, more capacity. It turns out there's now solid state drives, so there's SSDs, they're much faster, but still not as fast as RAM. So, you know, RAM is there to actually give you that edge when you're working with something, so that it's responsive, you know, that it's there when you need it, and that you can operate with it in a fast manner. And let's just take a quick look at the difference between SSD and hard disk. So SSD is actually much smaller than the hard drive, right? And interestingly enough, it's more than 10 times faster. There's even faster ones now. So SSD is quite a deal. There's now the question of what holds the memory longer in terms of how many decades, but the great thing about SSD is that there's no moving parts. So you've seen the hard drive, there's like a CD thing going on, right? So something rotates, you know, 5 or 6 or 7,000 rotations per minute. So the fast ones are 7,200 rotations per minute. So, you know, that thing has to rotate for quite a bit. And solid state drive is much better because there's no moving parts. The general thought, the general process in design or engineering is, you know, give me the least moving parts you can, and that's going to be more reliable because there's nothing that it can break. Another component that nobody talks about, is not exciting, but is very powerful and very important, is the power supply. So the power supply allows you, it's the food to your computer. It allows it to work because it provides power and converts AC to DC, so alternating current to direct current, and basically Tesla's current to Edison's current. So there you go. And basically anything that has a motherboard or some kind of circuitry of that sort works on direct current. When you buy the monitor and there's like a black box, you plug that in, there's a box, and then the cable goes to the monitor. So that's actually the power supply, the converter, the transformer from AC to DC, because components in computers, monitors, and electric devices need direct current in order to operate. What's interesting to me is that the motherboard as it is could be much smaller and much smaller and much smaller, and there's how can we even say this not to sound strange? So here on my Apple Watch, there's the same kind of motherboard that I just showed you, and the one I showed you is huge, right? And they found a way to actually make it so compact that it can be on your wrist. So the thing is, everything from electrical devices, from watches to your car navigation system, to your phone, to your laptop, has the same kind of motherboard. Has CPU, RAM, hard drive. Every one of these has to be there in order for any kind of computer to operate. So anywhere you look has some kind of motherboard. But now it's the question, have they figured out a way to compress it so that it can go on your wrist? They found a way. But think about it. Isn't that strange? So let's talk about different layers of the computer system and how do they work. So when you think about it, in essence, there's really only these 5. The first one being the hardware. The hardware is, of course, the physical thing, right? So the hardware is the CPU, RAM, GPU, hard disk. We forgot to mention GPU, but let's say it's just CPU dedicated to graphics and monitors. Let's say that's it. So hardware is the physical thing, right? And it's nothing without the next part. The next part is called firmware. Firmware is I don't want to say primitive, but it's simpler software baked into the hardware. So, in order for the hardware to even be visible to the computer, there has to be some kind of software that actually makes it alive, with some kind of soul to the hardware, right? So firmware is on a specific hardware part, and it allows it to work coherently with other computer parts. There's now an interesting thing called kernel. It's a layer that translates the languages between what you're trying to do and what computer has to do in order to fulfill your command. And kernel makes sure that when you click save on your computer, the hardware, the hard disk actually saves it physically onto it. So it makes sure that all the parts of hardware and software are connected so that the computer actually listens to you and executes. Operating system, you know this one very well. It's Windows, it's macOS, it's Linux, it's what you're currently using probably, it's iOS, it's Android. So these are all operating systems on top of these layers. And of course, the last one, what we know very well, is applications. So applications is of course everything you use, right? Like Word, like Google Chrome, like Safari, like even system preferences. So these are all applications for a computer, and you use them, and the chain goes down and down and down. And what actually happens in computer in background is, you move the cursor, and in background it's 0 1 0 1 0 0 0 0 0. You click on something 0 1 0 1 0 0 1 1 1 1 0 0. So isn't that strange? That's strange, but that's what happens. It's true. And as the last one, this is going to be a simpler one. So the last one is how you interact with computer and how it interacts back. So there's input and output devices like trackpad, mouse, keyboard. These are all the things that input something and relay information to computer and gives it data to actually process something, right? So you click A on your keyboard, it inputs it as a 1 0 1 1, and then it gives you back the visual representation of what you just typed. So that's the output. Output from computer is actually computer monitor, is actually speakers. If the computer starts playing if you play a song, output is actually speakers. And that's again an interplay of you inputting the data and computer giving you the information back. So this is just a brief intro about input and output devices. That's going to be it for this one. Thanks for watching, and now we know some pretty basic essentials about computers. See you soon. Bye bye.